Perfect. Thank you. Thank you very much, Louise. I'll see if I can share my screen now. Okay. So, yeah, my name is Mel Woods. I'm going to be talking a little bit more around taking a step beyond and into data gathering and analysis and to co-design. So collaborative design means designing a multi-stakeholder platform of citizens, policymakers to collaborate together and frequently monitoring critical problems that are local to them, but also are relevant on a global scale. And I'm talking in the context of a citizen observatory, which is a facet of citizen science, where people generally use the mobile devices, low-cost sensors, that's DIY or commercial, to create observations and records around particular issues. So I'll talk in particular about the GROW Observatory, which was monitoring soil moisture as a key role, has a key role in climate regulation, influencing weather systems, of course, and key for land use and food production, and is currently monitored remotely, of course, and used in climate services and disaster management. So we had a scientific objective, which was top-down, which was for the validation of remotely sensed soil moisture using in situ measurements, improving climate services related to extreme climate events, as we've discussed. But we also had a vision to look at the bottom-up engagement of people, and people who were using the land themselves, who actually were interested in generating and sharing and using that data for themselves in different contexts in different parts of the world, using that for soil health and for growing food and for land practices, and then also to address urgent climate challenges for science and society. So why might you use co-design? Well, it's a bottom-up. It enables a meaningful, deeper, longer-term engagement, which of course is highly relevant if you're thinking about long-term change in goals such as the SDGs. It enables people to foster a kind of multi-level governance, connections for different types of stakeholders, from citizens to local authorities to science partners, NGOs, and a policy level also. It offers opportunity to make positive change, and we can design towards change in order to identify the changes that communities might want to make, as well as those changes that citizens and scientists want to work on together, and then to work towards the SDGs as a coherent, integrated framework. I think one of the main advantages also in co-design is to create a space to facilitate relevant debate around big open data and around decoupling SDGs potentially from economic growth, and around some of the capabilities that we've talked about in the digital twin. So essentially we're turning data into knowledge for change and moving from data to meaning towards action and change, and all of those steps supporting our citizens and our communities to work with them, which is a highly engaged way of working. So we have a framework and methods for engaging stakeholders. They often identify an issue or gap and for a new initiative at local level to create a new ecosystem. And here on the right, you can see an image of people working together to look at the way data might move in and out of a particular initiative. And here it is around food and hunger and drought. We motivate and engage and plan with stakeholders to form and take action, and we identify what those actions might be collaboratively, and then we find the right team in order to underpin the observatories. And here you can see an example of some of the variety of communities that we involved in GROW, and all of the places that they engaged from, and the stories that they started to tell about their journey along with us. So co-design monitoring, what does it do? It enables communities to make decisions, give them methods to monitor the local environment. They can plan how and what they will measure, how often, by whom. They design together with which technology and tools are going to support the data collection for environmental and geographic dimensions. And we look also at indicators to measure the progress of the project in line with community goals. Of course, many of our goals are long-term, are not within the funded lifetime of these sorts of projects, but we can look towards major goals and then track back and monitor our way towards certain milestones, thus ensuring that we both reach those milestones and that communities are aware that they're making progress. So one of the things, the results that we've got from this approach, we had 24 geographically diverse grow places, all collecting soil moisture, placing over 6,500 sensors in the ground as of 2019, over 5 million rows of data in the sensor data set, which was continuously monitoring the 4 parameters that we see here: soil moisture, temperature, light level, battery level, and that was the time span for the data. So the conclusion, with the support both of the top-down scientific framing, but the bottom-up nature of working with communities and also opening data so both science and communities can use that data to make change at the local level as well as a large-scale scientific level, we created a high-density network of soil sensors defined according to scientific needs and the social possibilities. The novelty really was the spreading and the scale of that. So the model is viable and demonstrated in the high-density clusters that we call grow places. And in each place, there was a community champion who managed the community, the local expertise, the relevance and the distribution of resources, and then maintained that knowledge at the community level. So they created more resilient communities in terms of the skills in which those communities came to and left with. And they were left with these resources. So they owned the low-cost sensors in the end. They worked with the field handbooks for the ideal installation and sensing practices, and they became aware of data awareness and uptake and were able to apply that for themselves. For anybody who's interested in this type of approach, then you can access a starter kind of kit for this book, and I'll wave a copy in front of the camera here. These are the sorts of co-creation, co-design methods that you can introduce to citizens if you're interested in this, and you'll find if you do a search for the citizen sensing a toolkit online, free to download resource, and you can take a look. And with that, I'll finish my presentation. Thank you.
Wow, you're all so disciplined. And another brilliant talk. Thanks a lot. Now, actually, I have a copy of that in my office, which I didn't visit for quite some time now, but it's there. It's there. Brilliant stuff. So here we go, Luis, the full thing: overall structure, SDG, citizen science, example from Earth observation, and all the way to co-design. Quite amazing, isn't it?
I know, I like it. It's like, you know, at the beginning, taking that step beyond, you know what I mean? And one of the things that come to my head when I was listening to all of this is I couldn't stop thinking about the SDGs, you know, and goal 11, 13, and 17 just come to my head. It's like, you know, 11 for sustainable cities and communities, 13 for climate action, and then the 17 about partnership for the goals. And it's because it's giving that a partnership for sustainable development. You know, once you have all these tools available there, then it's like boom. So you have access to it. You got the different applications, and that's cool. Also, I like that citizen sensing toolkit. I think, Mel, I'm not sure how we're going to do this, but we need to bring one to Brisbane here. So I haven't seen it yet. So I definitely have to get a copy of it.
Absolutely, yeah.
Yep. So. Sven, so there is some questions, some things that have come up. So I'm not sure. What do you think? Maybe we can just go with few of the questions. Maybe ask the panelists if you guys would like to have a go and answer in there. Just put your camera up. Just you go with it. What do you think, Sven?
Absolutely. Yeah, please. If everybody could switch on the camera and the microphone when you speak, but certainly already the camera. And then we go through some of the questions that already commented in the chat, and we also have a few ourselves. Maybe we spare you the big question. We'll see, but we'll have a few also for you. So yeah.
So I got one here. So the first question I got for the panelists is, how do you see the connection between your work and the Digital Earth edition and its applications? I will just repeat the question. How do you see the connection between your work and the Digital Earth vision and its applications? I think Mel want to say something. Right?
I suppose, so it's Mel here. I suppose in the case of Grow, we were creating obviously a digital ecosystem for data to validate Earth observation in a sense, in a small scale way, and through that also starting to enable that kind of future thinking about and predictions about how data may be used in the future as well. So on a very small scale with that one project, we were looking both at a very grounded local physical sort of Earth observation from people, but we're also creating the digital data space as well for all of that work to happen. So I think it's in the, I guess maybe the digital ecosystem in effect is a small example of what could be contributed to the digital Earth vision, and it becomes very interesting when you see the interaction of communities as well as scientists in that project. But I can hand over to others.
Yep. Maybe is it okay? Yes. Just to complement to what Mel said, I think if we look globally at different places in the world, now beyond what is done in the Western world, where we have quite a very rich data ecosystem in many places, there are a lot of places in the world where we don't know even how many people live in that country, where we don't even know where people actually live, where the population and how the population is spatially distributed, and only models can tell us this. There is a big lack in information, in data itself in a lot of countries. So if you look at the SDG monitoring framework and the overall costs to monitor each indicator, for example, the costs are tremendous, and a lot of countries are simply not able to do that, to undertake that monitoring. So Earth observation, on the one hand, has really a big potential to close some of these existing data gaps. And additionally, I think citizens should not, and we said that repeatedly, should not just be seen as data providers and not only as sensors, but additionally, if many times a local problem, at the same time as solving that local problem or working towards solving this local problem, data is being collected and can then be really be used to close these big data gaps which exist. So I see the alignment really nicely be due to those big data gaps we have, and it's about finding intelligent ways of linking the needs of people with the more wider data needs of the SDG monitoring community, for example. Thanks.